For page 7, number 1, we're asked to give the solution set for this equation, and we're given a replacement set, possible solutions for the letter x. From this replacement set, do any of these elements work for x? Well, 2 plus 5 equals 7, so the answer for x is 2. We want to write our answer in braces because we're asked for the solution set. We're asked for a set, so you use braces around your answers. Number 3, from this replacement set, do any of the elements work for the letter v? Well, they don't, because it would be 3 plus 3, which would be equal to 6, and 3 is not in that set. So the answer is empty set. Number 11 is a true or false question. Algebra class is an element of set M such that M is a biological science. This is basically saying algebra is a biological science. That's false. Biological sciences would be biology class, anatomy class, botany, zoology, not algebra. Number 16, the set containing 4 is a subset of set Y, such that Y is an integer and Y times 3 equals 3 times Y. Is 4 an integer? Yes, it is. Does 4 work here for Y? 4 times 3 equals 3 times 4? Yes, it does. So this is true. For question number 4, we're asked to list the members of set V, such that V is a planet. So this is asking us to list the planets. Just write them out. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and at one time Pluto was considered a planet. Number 5, same direction. List the members of set K, such that K is a positive even integer. The first positive even integer is 2. Next comes 4, then 6, then 8, and write ... to show that this continues. Question 8, list the members of set S, such that S is a positive integer, and it has to be one more than a multiple of 3. So first let's think about the multiples of 3. The first multiple of 3 is 3 itself. One more than that is the number 4. So one element of set S is 4. Now what's another multiple of 3? 3 times 2 is 6. And one more than that is the number 7. So the number 7 is an element of set S. Another multiple of 3 is 9. And one more than that is the number 10. And so 10 is an element of set S. This list is going to keep going, so at some point we need to write ... Number 9, let's list all sets R such that R is a subset of the set containing 0 and 1. One subset of 0, 1 is the set containing 0. Another subset is the set containing 1. And another subset is the set containing 0 and 1. Any set is a subset of itself because that's one way of grouping all the elements together. Finally, the empty set is considered by mathematicians to be a subset of every set. That would be selecting neither of the two elements. So number 9 has 4 subsets. Number 13, list all sets M such that M is a subset of set X, where X is an integer and X is equal to X plus 4. When we think about what X might be, there is no number where the number is equal to itself plus 4. So the answer for number 13 is the empty set. Now page 4, number 16 is a true or false question. Is the set containing the even integers a subset of the set containing 2, 4, and 6? For this first set to be a subset of the second set, every one of these must be in the second set. So this answer is false. There are an infinite number of even integers. Whereas this set here only has 3 members. By the way, if this had been in reverse order, then we would have answered true. The set containing 2, 4, and 6 is a subset of the even integers. Number 23 asks, is the set finite, meaning it's countable, or infinite, meaning it has an unlimited number of elements? The residents of North America. There is a specific number of people that live in North America, so this is a finite set. It would take a long time to count all those people, but it would be countable. Number 26, the common fractions between 0 and 1. This is infinite because there are an infinite number of fractions that you can create that are between 0 and 1. Just a few of them would be 1/2, 1/3, 1/4, 1/5, 1/6, and so on. All of these fractions exist somewhere between 0 and 1. Next, number 3. The directions in the book say determine what symbol to fill in for the question mark. I've replaced the question mark with the box. What number times 14 is equal to 5 minus 5? Well, 5 minus 5 is 0. So what number times 14 is equal to 0? That would be 0. Next, number 13. What do you put in for the box? 6 times 8 is 48. 48 divided by 2 makes 24. On the right side, 3 times 4 is 12. So we don't want to put an equal symbol in the box. We either need to say that 24 is not equal to 12, or we could say 24 is greater than 12. Either is fine. Next, number 26. We're given that set U has the elements -7, 27, and 14. We're asked to list all subsets of that set. There are also subsets of the set containing the multiples of 7. So are any of these numbers multiples of 7? That would be -7 and 14. -7 is -1 times 7, and 14 is 2 times 7. Those are multiples of 7. Let's form all the possible subsets that have those numbers. One is the set containing -7. Another is the set containing the 14. And another subset is the set containing the -7 and the 14. Finally, recall that the empty set is a subset of every set. Number 29, is there one-to-one correspondence between the set containing the states in the United States and the set containing the senators of those states? Well, there are 50 elements in this set. This set has 100 elements because there are 100 U.S. senators. Every state gets to send 2 senators to Washington, D.C. Because they don't have the same number of elements, the answer to this question is no. Number 32. Does the set containing the even natural numbers less than 15 have one-to-one correspondence with the set containing the odd natural numbers less than 16? Let's figure out how many elements are in each set by listing them. The first even natural number is the number 2. Then 4, 6, 8, 10, 12, and 14. The first odd natural number is the number 1. And then 3, 5, 7, 9, 11, 13, and 15. Do these have the same number of elements? 1, 2, 3, 4, 5, 6, 7 elements. And over here, 1, 2, 3, 4, 5, 6, 7, 8 elements. So there is not one-to-one correspondence.